Hello students, this is Nikilian, Assistant Professor, Department of Civil Engineering, AJIT, Mangaluru. Today in this session, I am going to discuss about the pavement construction. So in this session, I am going to tell you about how the pavements are constructed and what are all the materials used in the construction of pavements. So let us see what are all the things we have to discuss in this module. So it is a new module, that is module 4 as per your syllabus. So pavement construction. So specifications, construction steps and quality control tests for granular slab base course, granular base or sub base course such as a WBM, WMM, CRM. So these are all the methods which are employed in the construction of granular subbase or in the construction of granular base. So in this module we are going to discuss about the specifications and construction steps and construct and quality control methods in the construction of granular base by different methods. So next is bituminous binder course like BM and DBM, common types of bituminous surface courses such as prime coat, track coat, surface dressing, premixed carpet, and bituminous concrete and rigid pavements. So these are all the things. These are all the things we are going to discuss in this module. So let us see one by one. So firstly, I will start with granular subbase. So you all know what is granular subbase. In previous module, we have discussed what is granular subbase and what are the properties of granular subbase and why it is important to take care of the construction of granular subbase. So granular subbase is a soil and this granular subbase is the integral part of road pavement structure. So this granular subbase will directly receive the traffic load from the pavement layers. Hence, the subgrade soil and its properties are very important in the design and in the construction of pavement structure. And here, the main function of subgrade is to give adequate support to the pavement, and this subgrade should possess sufficient stability under adverse climate and loading condition. And when the vehicle moves over the pavement surface, there is a formation of waves, corrugations, rutting, and showing in black cotton soil pavement, and hence the granular subbase should be strong to take up all this loads and different types of phenomena. Now let us see what is the scope of this subbase soil. So this work shall consist of laying and compacting well graded materials on prepared subgrade in accordance with the requirement of this specification. So when we use the material in the construction of pavement, the material is laid over a ground surface and then it is compacted well. So here in this slide you can see which type of material we are using in the construction of granular subbase. In the construction of subbase we are using a mixture of gravels and fine aggregates. So this material we can use in the construction of granular subbase, and it should be properly laid and it should be well compacted. Hence the well compaction decreases the void ratio. If the compaction is not done properly, then the voids present in the subgrade will be more, which will influence for the percolation of water and reduces the strength of the subbase. The materials. So what are the materials and what are the properties of materials used in the construction of subgrade? So the materials to be used for the work shall be natural sand, moram, gravel, crust stone, or combination of thereof depending upon the grading required. So the materials used in the construction of subgrade includes natural sand, moram, gravel, crust stone, or the combination of all this is used as a material for the construction of subgrade soil. So the combination depends upon the grading requirement. So for different projects, depending upon the importance of projects, the materials will be, the combination of materials will be designed. So here we have different size of gravels. We have a river sand which is mixed with gravels, and you can see the size of gravels is not same. So here it is large and here it is small. So this is dependent upon the grading system, and it sometimes it also depends upon the importance of the work. The materials like crust slag, crust aggregates, brick metal, and concur may be allowed only with specific approval of engineers. So the materials which are naturally obtained, not only this materials can be used, we can also use the crust slag, crust concrete, brick metal, and concur. So these are the recycled materials. So crushed concrete means it is a recycled material, or it is obtained from the demolition of buildings or any other structure. Similarly, brick metal, it is also obtained from the demolished buildings or from the any other structure which has been demolished. So these materials can also be used in the construction of subgrade soil, but for the use of these materials in the construction, the materials should be specified, and the engineer who is involved in the designing and construction of the pavement should give approval for the use. The maximum size of materials used are 75 mm, 53 mm, and 23.5 mm. So the size of the aggregates or size of the materials which is used in the construction of subgrade is 75 mm, 53 mm, and 23.5 mm. So these are the maximum sizes of the aggregates used in the construction of subgrade soil. So here you can see a table. So in this table, in the first column you can see a sieve size. Here you can see sieve size, and here you can see percentage by weight passing the IS sieve. So here it is grade 1, grade 2, grade 3. For example, if 100% of a sample is passing through a 75 mm sieve, then it is grade 1. Similarly, if a sample passes through a sieve of size 53 mm and the sample ranges between 80 to 100% means, then it comes under grade 1. Similarly, if I consider a sieve size of 26.5 mm and the sample passing through this sieve is between 55 to 90%, then it comes under grade 1. Similarly, grade 2. So for the grade 2, if a material passes through a sieve of 53 mm and the percentage of material passing is 100%, it comes under grade 2. If a material which is sieved through 25.5 mm and the material passing in this sieve is 70 to 100%, it is grade 2. Similarly for grade 3. And we have different values. It is a minimum value for a soil when we go for CBR test. So the CBR value for grade 1, grade 2, and grade 3 is given here. So for grade 1, the CBR value is 30. For grade 2, CBR value is 25. For grade 3, CBR value is 20. So these are the minimum values for the soil which is used in the construction of a subgrade. So in the second table, in this table, we can see the grade system for coarse graded granular subbase material. So here also it is same grade 1, grade 2, grade 3. So if a material passes through 75 mm sieve and the percentage of passage is 100 mm, then it comes under grade 1. Similarly, for grade 2, if a material passes for a percentage of 100 mm through a sieve size of 53 mm, then it comes under grade 2. Similarly, in grade 1, if a material which is sieved through 26.5 mm and the percentage of passing is between 55 to 75%, then the material comes under grade 1. So here we have different percentage of passing through different sieve sizes, and depending upon the percentage of passing through respective sieves, we have different grading systems like grade 1, grade 2 and grade 3. So as of in the first case, here also we have minimum CBR value for coarse graded granular subbase. So for the coarse graded granular subbase, for grade 1, the minimum CBR value should be 30. For grade 2, the minimum CBR value should be 25. And for grade 3, the minimum CBR value should be 20. So after knowing the gradation for the materials which is used in the construction of subbase, now let us see the next requirement for the material. So next is physical requirement. So what is a physical requirement? Let us see what are the physical requirement for the materials which is used in the construction of the subbase course. The water absorption value of the coarse aggregate shall be less than 2%. So here the aggregates, that is the coarse aggregates which are used in the construction of subbase or subgrade, should have a water absorbing capacity of less than 2%, and this is determined by taking the weight of dry aggregate, and after knowing the weight of dry aggregate, the coarse aggregate is kept in a water for 24 hours, and after 24 hours the aggregates are removed from the water and it is kept in a open air under room temperature for 30 minutes. So after the surface undergoes drying, the material is again weighed, and let us consider that weight as W2. So W1 be the weight of aggregates in its dry condition and W2 be the weight of aggregates after keeping it for after keeping it in water for 24 hours. And by knowing the weight of aggregates in wet condition and in dry condition, we can determine what is the water absorption capacity of a coarse aggregate. And the water absorption of a coarse aggregate should not be more than 2%. So the maximum is 2%, or it should be less than 2%. If it is less than 2%, then it is well and good, but it should not be more than 2%. Then what is the second physical requirement? If it is more than 2%, soundness test shall be carried out. So if it is less than 2%, the aggregates are well and good for the use in the construction. Suppose if the water absorption capacity of coarse aggregate is more than 2%, so in some worst cases we may experience these conditions. So under such circumstances, what we can do? So if we come to know that the absorption capacity of a coarse aggregate is more than 2%, then we should go for the second test, that is soundness test. So here the intended to study the resistance of aggregates to weathering action by conducting accelerated weather test cycles. So the porous aggregates subjected to freezing and thawing is likely to be disintegrated prematurely. So to ascertain the durability of such aggregate, they are subjected to an accelerated soundness test as specified in IES 2386 part 5. So here the aggregates of specified sizes are subjected to cycle of alternate wetting in saturated solutions of either sodium sulfate or magnesium sulfate for 16 to 18 hours, and then it is dried in oven at a temperature of 105 to 110 degrees Celsius to a constant weight. So after 5 cycles, the loss in weight of aggregate is determined by sieving out all undesired particles and weighing, and also loss in weight should not exceed 12% when tested in sodium sulfate and 18% when tested in magnesium sulfate solutions. So if the material qualifies, or if the material passes this test, then we can use the material in the construction of the sub base. The material passing 425 micron sieve shall have LL and PI not more than 25 and 6% respectively. So the material which passes through 425 micron sieve should have the liquid limit and plastic index not more than 25% and 6% respectively. The liquid limit and plastic index should be below 25% and 6% respectively. So next is strength of sub base. So what is the strength of sub base and how the strength of sub base is determined? Let us see. It shall be ensured prior to actual execution that the material to be used in sub base satisfies the requirement of CBR and other physical requirements when compacted and finished. So the material before it is used in the construction of sub base, the material should be tested in the laboratory or the materials should be tested in the field. So when we test the materials in the laboratory, the materials used in the construction of subbase should satisfy the requirement of CBR and other physical requirements. So in previous slide we saw that the table for different grades like grade 1, grade 2, grade 3, we have different CBR value. Like for grade 1 it is 30, for grade 2 25, for grade 3 20. Similarly in case of coarse graded granular subbase we have different values for CBR test. So the materials which are used in the construction should achieve that value depending upon its gradation. And after knowing the strength of a material by conducting a CBR test, the material is used in the construction of subbase. So after knowing the physical properties and after knowing the strength of a material by different laboratory tests, next is construction operation. So how the construction of a subbase is executed. So what is the procedure for the construction of subbase or for the construction of granular subbase? So the first step in execution of construction of granular subbase is preparation of subgrade. So subgrade is a layer which is laid above the natural ground profile. So let us see how we should prepare the subgrade. So prior to the laying of subbase, the subgrade shall be prepared by removing all vegetations and other extraneous matter, lightly sprinkled with water if necessary, and rolled with 2 passes of smooth wheeled roller. So subgrade is a layer which is below the subbase. So before laying of a subbase, the subgrade should be prepared. So how to prepare a subbase or how to make a subbase suitable for the laying of next layer over it. So here before laying of granular subbase, the subgrade is being removed from all the vegetations. The subgrade is sprinkled sprinkled with water. So water means a minimum quantity of water, and if it is necessary, the subgrade is rolled with 2 or 3 passes of smooth wheeled roller. So what will happen when the subgrade is rolled with a roller? If there is any pores, or if there is any warts in the layer or in the course, that warts will be filled with the soil particles. Hence, the subgrade will become stiff and it will be strong to take up the loads which is coming from the traffic. What's the second step? Spreading and compacting. The subbase material of grading specified in the contract shall be spread on the prepared subgrade with the help of motor grader of adequate capacity, its blade having hydraulic controls suitable for initial adjustments and for maintaining the required slope and grading during the operation, or other means approved by the engineer. So after preparing the subgrade, the aggregates or the materials which is used for a subbase is spreaded and the material is compacted over the subgrade. The material is spread over the subgrade using a motor grader vehicle of adequate capacity, and the materials which is used should be as per the specification in the contract, and the motor which is used for the spreading of this material will be having a blade, and it will be having a hydraulic controls which is suitable for initial adjustments and for maintaining the required slope and grade during the operation, and other means as approved by the engineer. When the subbase material consists of combination of materials, mixing shall be done mechanically by mix in place. So as I told you in the beginning, we are not only using single material in the construction of subbase. So we are using a combination of materials. So we will use coarse aggregate, fine aggregate, smorum, etc. So when we are using the combination of materials in the construction of subbase, then the mixing of these materials should be done properly, and this mixing shall be done mechanically in the site. So manual mixing shall be permitted only where the width of laying is not adequate for mechanical operation. So we should mix the materials in case of combination of materials in site by using mechanical means. So that is our first condition. Suppose if mechanical operation is not possible in the site due to the inadequate width for mechanical operation, then in such cases the materials can be mixed manually if it is permitted. So after spreading and compacting, next comes surface finish and quality of work. So all works performed shall conform to the lines, grades, cross sections and dimensions shown on the drawing or as directed by the engineer, subject to permitted tolerance. So once this two steps is constructed, when preparation, first one is preparation of subgrade, then spreading and compaction of the material. The next process is surface finish and quality of work. So here the surface finish should be as per the guidelines and as per the grades which is mentioned in the contract, and the quality of work should be good, and there is some concession for a contractor who involves in the construction of a work, and the work what he has done should be within the permitted tolerance limit. So if it exceeds the tolerance limit, then the work has to be redone. So the tolerance limit is mentioned in the section 900. So as per the guidelines given in the contract and specifications mentioned in the contract, the work has to be completed. Control on the quality of materials and work shall be exercised by the engineer in accordance with section 900. So the engineer who is responsible in the construction of pavement, he should check the quality of material as per the section 900. So after that step, what is the fourth step? And the fourth step is arrangement of traffic. The contractor shall at all times carry out work on the highways in a manner creating least interface to the traffic flow while consistent with the satisfactory execution of the same. For all works involving improvements to the existing highways, the contractor shall, in accordance with the directives of engineers, provide and maintain during execution of the work a passage for traffic either along a part of existing carriageway, tender improvement, or along a temporary diversion constructed close to the highway. The contractor shall take prior approval of the engineer regarding traffic arrangement during construction in accordance with clause 112. The contractor who involves the construction work in a payment should provide a temporary road for the traffic movements, or you should involve in the construction of highway in such a way that you should not disturb the traffic flow, and the disturbance or interface to the flow of traffic should be minimum. So it should involve in the construction of work in such a way that the traffic flow should be normal. There should not be any interruption for the traffic flow. So how we can carry out a construction of highway without interrupting the traffic flow? So there are different ways to provide a path for the movement of traffic during the construction. So here the contractor, in accordance with the directives of engineers, he can provide a carriageway beside the construction work going, or else he can also provide a temporary road which is nearer to the highway, and the contractor shall take a prior approval from the engineer regarding traffic arrangement during the construction. So without consulting the engineer who is involved or who is in charge of this construction work, the contractor can't provide any provision for the traffic. So prior to the construction of a temporary road or a diversion, it should take a approval from the engineer. So measurement for pavement. This is for measurement for payment. So after construction, the bill has to be given for a contractor. So for the payment of a bill, we should measure what is the work done by a contractor. So whether he has done the work as per the specification of a contract, or he has done an incomplete work. So the payment will be done based on his work and based on the quality of work. So GSB, granular subbase, shall be measured as finished work in position in cubic meters. So before sanctioning a bill for a contractor, the work done is measured in terms of cubic meters. So after measuring the work done and the quality of a work and the quality of a materials used in the construction of a subbase, the payment is sanctioned to the contractor. So rate. So how the rate is fixed? On what basis the payment is done to a contractor? The contractor, the contract unit are for granular subbase shall be payment in full or in full for carrying out the required operations including full compensation for. So how the payment is done for a contractor? So how the rates are fixed? So rates are fixed by considering all the expenditure what he has done for the construction of a payment. So let us see how the rates are fixed for different works and what are all the works that will be considered in fixing the rate for a contractor. So first one, making arrangements for traffic flow, class 112, except for initial treatment to verges, shoulders and construction of diversions. So payment will be made including the expenditure which is made by the contractor for the arrangement of traffic flow. The second one, furnishing all materials to be incorporated in the work, including all royalties, fees, rents where necessary, and all leads and lifts. So the bill of a project also includes the rent of a material which is brought for the construction of a payment. So it includes fees which is paid for the materials which is paid for the materials used in the construction, rents and the other necessary materials like lifts and leads. So considering all these materials which is used in the construction, the bill is sanctioned. All labors, tools, equipments and incidentals to complete the work to the specification. So while billing for a project, the billing person or an engineer will also consider the total cost which is involved for the labor and the total cost involved for equipments, for tools in the construction of a sub base for the payment and incidentals to complete the work as per the specification. So including all this, the billing is done. Carrying out the work in pan widths of road were directed and carrying out the required test for quality control. So when we go for any project, it may be the construction of a building or it may be a construction of payments, the strength of a material should be tested. So for testing of this materials, the materials will be sent for a labs or it will be sent for some consultant agents. So the contractor will also spend the money for testing of the materials. He has to pay for a consultancy as a charges for the test. So the billing also involves the amount which is spent for the testing of a materials by the contractor. So by considering all this, the final bill will be sanctioned to the contractor. Now let us come to next thing, that is Waterborne Macadam, which is commonly known as WBM. This Waterborne Macadam, it is a granular road which has been constructed since from 190 years. And here the Waterborne Macadam is a construction which is known after the name of John, and the term macadam in the present day, the meaning is the pavement base course which is made of crushed or broken aggregates. So let us see what is this waterborne macadam, what are the scopes and advantages, if there is any disadvantages, and how the road, that is how the granular road or how the Waterborne Macadam road is constructed. So first is a scope for WBM. This work shall consist of clean crust aggregates mechanically interlocked by rolling and bonding together with screening binding materials where necessary and water laid on properly prepared subgrade or subbase or base or existing pavement as the case may be and finished in accordance with the requirement of these specifications and in close conformity with lines, grades, cross sections and thickness as per approved plan or directed by the engineer. Here, Waterborne Macadam work consists of clean crust aggregates and this aggregates which are mechanically interlocked by rolling and bonding together with screening binding materials. If necessary, some quantity of water is laid for this cleaned crust aggregates before it is mechanically interlocked by rolling, and the layer of this WBM is laid over a prepared subgrade or a subbase or a existing pavements, and the work is finished as per the specification of contract or as per the requirement, and the thickness for Waterborne Macadam is provided as per the approved plans from the agencies or from the engineer who is involved in the construction of this work. It is, however, not desirable to lay waterborne macadam on an existing thin black topped surface without providing adequate drainage facility for water that could get accumulated at the interface of existing bituminous surface and waterborne macadam. So the construction of this granular road, that is waterborne macadam, is not suitable over the black topped surface. That means we cannot construct waterborne macadam road over a already existing road, because if we construct a waterborne macadam road over already existing road or over a bituminous road, then there may be a problem for draining of water which percolates from the top surface of waterborne macadam road. So this water will be accumulated at the interface of two different layers. That is, the water will be accumulated between the bituminous surface and below the waterborne macadam. So this may leads to the damage of waterborne macadam performance. So in this picture we can see the construction of WBM, that is waterborne macadam. So the surface is being prepared, that is, this is a surface, it may be a subbase or a subgrade. So this is first prepared, and over this a clean and crushed aggregates is laid, and these aggregates are compacted using a roller. So this aggregates, if it is necessary, can be treated with the water. So this is the first stage. So before compaction, if it is required, the water is sprinkled lightly over this aggregates, and then the aggregates are compacted using a roller. Hence the voids between the aggregates will be filled. So what are the materials used in the construction of WBM pavement or waterborne macadam pavement or a road? So firstly, a coarse aggregate. So coarse aggregate shall be either crushed or broken stone or crushed slag, overburnt brick aggregates or any other natural occurring aggregates such as concrete and laterite of suitable quality. So the first material let us consider as a coarse aggregate in the construction of waterborne macadam. So the coarse aggregate which is used in the construction of waterborne macadam pavement can be a crushed stone, or it can be a broken stone, or a overburnt bricks, or a naturally occurring aggregates like a concrete or a laterite stone, etc. So these materials can be used in the construction of waterborne macadam pavement if these materials are having sufficient strength as mentioned in the contract, and if the quality of materials are good. So next material, crushed or broken stones. The crushed or broken stone shall be hard, durable, and free from excess flat, elongated, soft, and disintegrated particles, dirt, and other deleterious materials. So the crushed stones or broken stones, which are used in the construction of waterborne macadam pavement, should be hard. It should possess a sufficient strength to take up the vehicular load, and the material should be durable. That means the lifespan of a material should be long, and the materials which is used in the construction should be free from excess flat and elongated materials. So the material should not be soft, or it should not consist of soft materials or a disintegrated particles, and the crushed aggregates or broken stones, when it is used in the construction, it should be free from dirt materials and other deleterious materials. And the other material is crushed slag. So crushed slag shall be made from air-cooled blast furnace slag. It shall be of granular shape, reasonable uniform in quality and density, and generally free from thin, elongated, and soft pieces, dirt, or other deleterious materials. It should also comply with the following requirement. First one is sulfur content maximum of 2%, water absorption maximum of 10%. So crushed slag, it is obtained by air cooled blast furnace slag. So this crushed slag shall be of angular shape, and it should have a uniform quality and density, and this crushed slag should be free from elongated materials, and it should be hard. There should not be any soft pieces within this crushed slag when it is used in the construction of waterborne macadam pavement. And also this crushed slag should be free from dirt and other deleterious materials. In addition to this, when crushed slag is used in the construction of waterborne macadam pavement, it should consist of sulfur content, and the sulfur content should not be more than 2%. So if the sulfur content which is present in the crushed slag is more than 2%, then it is not suitable to be used in the construction. Hence, the sulfur content in the crushed slag should be within 2%, and the water absorption capacity of this crushed slag should be a maximum of 10%. So if the water absorption capacity of this crushed slag is more than 10%, then the crushed slag is not suitable for the construction of waterborne macadam pavement. So here in this table, we have the requirements for the coarse aggregate. So for the coarse aggregate, if it is tested in the lab, what should be the abrasion value, or what should be the abrasion strength, what should be the impact value, and what should be the flakiness and elongation index. So this table is specified in IS 2386 part 4. So from IS 2386, the abrasion value for coarse aggregate should be 40%. It is the maximum value, that is the abrasion value should not be more than 40% when it is used in the waterborne macadam pavement. and impact value of the aggregate should not be more than 30%. If it is more than 30%, then the aggregates are said to be soft. Hence, the impact value of the aggregates should not be more than 30%. It should be within 30%. So, combined flakiness and elongation index. So, as per IS 2386 Part 1, the flakiness and elongation index of the coarse aggregate used in the construction of WBM pavement should not be more than 30%, because what happens when elongated or flaky aggregates used in the construction, if the flakiness index and elongation index is more than 30%, then the watts will be more. The aggregates will not fill the filled within the watts. So with increase in the watts, there is a decrease in the strength, or there is a decrease in the load taking capacity. Hence, the flakiness and elongation index should be within 30%. Or else, if the coarse aggregate used in the construction is elongated, then it will be having a sharp edges, and when this sharp edges subjected for a vehicular load, it will undergo braking. So when the material breaks, then it is said as that the material is failed under loading condition. Then overburnt brick aggregates. So Jama brick aggregates shall be made from overburnt bricks or bricks bats, and be free from dust and other objectionable and deleterious material. So we can also use the overburnt brick as an aggregate in the construction of waterborne macadam pavements. So when we use this overburnt brick aggregates in the construction, the bricks should have a sufficient strength to take up the vehicular load. The water absorption capacity of this bricks should be low as much as possible, and this overburnt bricks should be free from dust and other deleterious materials. So that is about the materials which is used in the construction of the waterborne macadam pavement. Now let us see the next thing which is employed in waterborne macadam pavement, that is screenings. So screenings to fill wards in the coarse aggregate shall generally consist of same materials as coarse aggregate. However, where permitted, predominantly non-plastic materials such as moram or gravels other than rounded riverborne materials may be used for this purpose, provided liquid limit and plastic index of such materials are below 20 and 6% respectively, and fraction passing 75 micron sieve does not exceed 10%. So screening means it is a process of filling up the watts which is present in the coarse aggregate. So we can also call the screening, the materials used in the screening, as the secondary materials used in the construction of WBM pavement. So here, when the pavement is constructed using the materials like overburnt bricks, coarse aggregate, or crushed slag, etc., there will be a watts between the particles, and this watts has to be filled, and the filling of this watts is called as screening. So this is done by same materials as of a coarse aggregate. So sometimes we will use materials which are non-plastic, such as maroon or gravels, and there is a condition that the materials should not be a round riverborne material. So this type of materials are used in the filling up of wards or in the screening. So this materials which is used for screening should have a liquid limit of 20% and a plasticity index of 6%, and The materials used for the screening should have should not have a passing fraction of through 75 sieve more than 10%. So the material which passes through 75 micron sieve should not be more than 10%. It should be below 10%. Then binding material. So binding material to be used for waterborne macadam as a filler material meant for preventing raveling shall comprise of suitable material approved by engineer having a plastic index value less than 6. So after laying the materials and after compacting the materials using a roller, the screening is done. That is, the voids are filled. So after doing all this, the material has to be binded with each other. So for this, we are going to use a binding material, and the binding material should be approved from a engineer who is in charge of a project, and the binding material should have a plasticity index not more than 6. That is, the plasticity index of a binding material should be less than 6. So binding material is used to prevent the sliding or to prevent the dislocation of the materials in waterborne macadam. Now let us come to the construction operation. So how the pavement is constructed? What is the procedure involved in the construction of waterborne macadam pavement? So firstly, preparation of base. The surface of subgrade, subbase or base to receive the waterborne macadam course shall be prepared to specified lines and cross falls arrayed made free of dust and other extraneous materials. So before laying a waterborne macadam layer, the layer which is beneath the WBM layer, it may be a subgrade, subbase or a base. So this layer should be first prepared. So if there is any extra material or if there is any unwanted things on this layer, it should be removed, and this layer should be prepared as per the specification given in the contract. So if it is necessary, this layer can be sprinkled with water and it can be given 2 or 3 passes using a lightweight roller. So after preparing the base or a sub base or a subgrade, the second step, spreading coarse aggregates. The coarse aggregates shall be spread uniformly and evenly upon the prepared subbase or subgrade or base to proper profile. The spreading shall be done from stockpiles along the side of roadway or directly from the vehicle. So after preparation of base, the second step involved in the construction of WBM pavement is spreading of coarse aggregate. So the coarse aggregate should be spread uniformly and evenly upon the subgrade or a subbase or a base. So this spreading of aggregate can be done manually or this can be done using the vehicles. So after spreading the coarse aggregate over the layer of base or a subbase or a subgrade, what is the next process or what's the third process? So the third process is rolling. So immediately following the spreading of coarse aggregate, rolling should be started with 3-wheeled power rollers of 80 to 100 kN capacity or Tadden or vibratory rollers of 80 to 100 kN static weight. So after spreading of aggregate, if it is necessary, the aggregates can be sprinkled with water, and after doing this, the aggregates has to be compacted. So for the purpose of compacting the aggregate, the roller is passed over the spreaded coarse aggregate. So here we can use 3-wheeled power roller of weight or capacity 80 to 100 kN, or we can also use a vibratory rollers of capacity 80 to 100 kilonewton static weight. So here the rolling is done to compact the material. So after compacting the material using the roller, the next process is application of screening. So screening means it is a filling up of voids using a secondary material. So after the coarse aggregates has been rolled, screenings to be completely fill the inters interstices shall be applied gradually over the surface. This shall not be dumped over wet at a time of application. Dry rolling shall be done while the screening are being spread. The screenings shall be applied at low and uniform rate so as to ensure filling of all voids. So after compacting the aggregates which are spread over a base or a sub base, and after the rolling of that, we should apply screening material for filling up of voids. And here the material screening material which is used for the fill up of materials should not be damp, or it should not be used under application of water. The screening material should be completely dry, and the roller should not have any water over its wheels. Even the wheels of a roller should be dry. And it should be noted that the spreading of screening material should be uniform. It should not be dumped at a place, or it should not be done rapidly, or it should not be done at very fast rate. The application of screening material should be uniform, and it should be applied in such a way that all the wards present in the aggregate should be filled, and a contractor should ensure the filling of wards is uniform and it is completely filled. Then the next step or the next process is sprinkling of water and grouting. After the screening have been applied, the surface shall be copious sprinkled with water, swept and rolled. So after application of screening material, the layer is sprinkled with water, and after sprinkling the water upon the layer, it is swept and rolled. So after this, the next step is application of binding material. So after the application of screening, the binding material where it is required to be used shall be applied successively in two or more thin layers at a slow and uniform rate. So already I told you binding materials are used to prevent the displacement of materials or to prevent the displacement of aggregates. So if we apply a binding material, there will be a good connection between two aggregates, or there will be a good bonding between different aggregates. Hence, we should apply binding material. And here, the application of binding material should be done uniformly, and it should be done at a very slow rate. And this binding material may consist of two or more layers, and the layers are very thin. So after applying a binding material, the next process is setting and drying. After the final compaction of waterborne macadam cores, the pavement shall be allowed to dry overnight. Next morning, hungry spots shall be filled with screening or binding material as directed. So after the application of binding material, the pavement is left, or it is allowed to for setting and drying. So it is allowed for setting and drying for a full night, and next day the contractor or engineer will visit the site with laborers, and they will inspect the they will conduct an inspection for full length of a pavement, and if they see any hungry spots, like there may be some gaps or there may be some wards between the aggregates or in between the pavements, so they will conduct an inspection and they will fill the wards which is present on the pavement using screening materials or binding materials as per the requirement. And the next process is surface finish and quality control of works. The surface finish of construction shall conform to the requirements of clause 902. Control on the quality of materials and works shall be exercised by the engineers in accordance with the section 900. So the surface finish of the construction, it should conform to the requirement of clause 902. So there is a specification for the surface finish in the clause 902, and the finish should be as per the specification, and the quality control of the materials and the work, it should be conformed accordance with the section 900. So what is the next step? That is arrangement for traffic. During the period of construction, the arrangement of traffic shall be done as per clause 112. So here, during the construction of pavement, it should be done in such a way that there should not be any interruption for the traffic flow. The traffic should be normal. So care should be taken to make a alternate arrangement for the traffic flow as per clause 112. So finally, it is measurement for pavement. So Waterborne Macadam shall be measured as finished work in position in cubic meter. So once the construction work is complete, the last stage or the last step is measurement for the pavement. So a contractor has to be paid for his work. So the work done by the contractor is measured in terms of cubic meter. So there are different processes or different techniques for the measurement of work done by a contractor. So after measuring the work done by the contractor, and if the work done by the contractor is satisfied, the engineer or a government agency will sanction the bill for the contractor. So finally, rate. So the contractor has to be paid for his work done. So how he is paid, like on what basis he is paid? So as I already told you, the contractor will be paid for his each work. Like if he has taken any material for a rent for the construction of a work, then the rent of that materials will be paid, and the complete labor charges, the charges for equipment, tools and any other things, it will be paid, and the arrangement what the contractor makes for the flow of traffic, that is the expenditure which is involved for the construction of alternate way or diversion, is also paid by the agency, and other works which are done by the contractor to ensure the quality of a materials, like you will pay for a consultancy or you will pay for a testing agencies to check the strength and quality of a material. So the amount what the contractor is paid for that agencies or consultancies will be paid from the government once after completion of the work. So this is the complete procedure which is involved in construction of Waterborne Macadam.